Hello, this is Vasant Williams, UR16CS089. Today I'll explain the program Syncly Linked List. So here I have defined each node, like one node. So it will have a data part and a pointer which will hold the address of the next. So I named it next. So in the main function I have a menu. The choice will be taken in C. So now I created a node called head, and I have initialized it to null because there is no node at the beginning. There is zero node. So I have a menu to add at front, add at back, add a position, delete at front, back, add a position, and then display. So if the choice is 1, C is 1, so we are going to add at front. So we will be creating a temporary node called temp, and then we are creating a temporary node here, and then we are entering the data which is to be added. So temp arrow data. So if head is equal null, so at the first case when there is no node, head will be equal to null. So if it is null, we are going to make the head as temp, and then next part of the head will be null. Else if there is already one or more nodes and we are going to add one more node, then we will be making temps, we'll be linking temps and head, and then we will be changing head into temp. So this way we'll be adding at front. Now adding at end, in the same way we'll be creating another node, and then we'll be taking data in it. If head equal none, that is if there is no node at all, like there is zero node at the beginning, then we'll be adding at end. In this way we'll make head equal to n, and then we'll be linking we'll be making the ends next, that is link part as null. As if there are one or more than one nodes already present, while adding at the end, we'll be having a node temp. We'll be equating, like we'll be making temp into head, and then while temp arrow next not equal to null. In this way we are going to move to the last net. Every time we will check if temp's next part is null or not. If it is null, this while loop will break, otherwise it will move on to the next node. So this way we are going to till the last node. After reaching the last node, we are going to do temp arrow next, that is temp is pointing to the last node, so temp's last node's next will be linked to the new node which we have created here, and then n arrow next. Since n is the last node, now we are going to initialize, we are going to put its pointer or link part as null. The third part is adding at a position. In this we are going to need a temp node to move through the node or traverse through the node. Now we have temp equal to head, pointing to the first node. We have a POS to take input from the user, which position he wants to input, and we have a count which first denotes the first node, and then it will be increasing accordingly. We'll do now. We'll be taking a new node called n. We'll be taking data, and then we'll ask the user at which position we want to add the node, and then if position equal to 1, that is if there's no node at all, then we'll be adding as we add at the front. Oh, uh, now we have while temp arrow next. This is again the same thing. We are going to move till the position which the user has input. This is to check if to move until the last node. We are going to move to the next node, and we are going to increment the count whenever count will be equal to POS minus 1. That is a, if the user has input position as 5, if you want to input at the position 5, we'll be moving the temp pointer till 4. When it reaches 4, we're going to put this is 4 arrow next equal to temp arrow next. So we are linking both the temp and the n, and then we are equating temp's next part as n. So in this way we have put n at that position. If count is greater than position that the user has input, that is after this while loop have run, if count is greater than POS, that means the user has input some number which uh, like that many nodes were not available, so we are going to display list smaller than the position given. In the same way, we want to delete at beginning. So we are going to create a node temp. We want to equate it to head. So temp and head will be pointing the first node. Uh, Head equal to temp arrow next. So head will take the position of the second node, and then we are going to delete the first node which is pointed by temp. Deleting at end. So we are going to create a temp node which will be used temp pointer actually. Then we are going to move that temp from first to end using this while loop and this statement. And then when we reach till the last node, sorry, we'll be going to the second last node. After going to the last node, we are going to create another pointer temp1, and which will be uh, also take the second last node, and then we are going to move temp to the last node, then delete temp. In this way, the temp1 will hold the second last node, which will eventually become the last node after deleting last node. And then we are going to display, sorry, we're going to change the last node arrow next equal to null, because last node will always point to null. And then this is deleting at a position. We are creating a node temp again to move to the specified position by the user. Then we have the same count as we had in adding at a position part of the code. So enter position at which we want to delete node, then we'll take input from the user, and then position, if position equal null, that is if there are no nodes, and we are going to delete the only node which is present. So head equal to temp arrow next, and then we are going to delete temp. If there are more than one nodes, then temp arrow next not equal to null. In this way, we are going to move traverse through the node, then temp is equal to temp arrow next. Whenever this is not null, we are going to move to the next node and then count. If we reach one node before the position where we have to delete, we are going to do this operations. So we will create another pointer temp1. We're going to equate temp1 and temp, so both will be pointing to the node which is one before the position the user has set. And then we are going to move temp1 to the next node, temp1 temp arrow next equal to temp arrow next. So we are going to move temp two nodes after temp initially it is, and then we are going to delete temp1. After that, we are going to display a message successfully deleted. This is a similar case which I explained in adding at a position. Now we are going to display, we are going to use temp. First we'll point it to the first node, and then we are going to display the first node's data, and then until we reach the until we are going to reach the last node, we are going to keep on displaying. That's it. Now we'll check the output. Adding at front, so we'll add 10, which will be at the first node. We're going to add at back 20. So first will be 10, second will be 20. We're going to display it 7. So we have 10 and 20. So we are going to delete at front. Sorry, we are adding actually. Okay, now I'll delete at back. Successfully deleted. Now I'll display. So I have 30 and 10. 20 was there, which was deleted. And then I'll delete at front and display. I have only 10 left. So that's it. Thank you.